Okay, so I know I'm probably a little late getting out a video, but I just wasn't really sure how to do it. So Aaron got me a tablet as a little writing pad and got the computers all set up, so now I feel like I'm ready. So I'm just gonna start you guys off with this short little video talking about this review. So review obviously, right? So we've already learned it, but we haven't practiced it in a while, plus we've been out of school for a while, so we'll go through back through a little bit. So real quick, I will just let y'all know that I am writing, but not looking where I'm writing. It's kind of weird, so my handwriting will probably be bad for a little while, but hopefully I'll get better quickly. But first off, okay, chemical formulas for following, whatever. Ionic and covalent. That's what I care about first, okay? This is what we need to remember initially. So covalent bonds are between two nonmetals, right? Okay, so ionic bonds are between a metal and a nonmetal. How do I know which one is a nonmetal? Worry not. We had a staircase, remember? Here's our little staircase. Okay, so if it's on this side, it's a nonmetal, and if it's anywhere on this side, it's a metal. So let's go do a few of these. So if we have sodium and sulfide, sodium here, sulfide here. Sulfide is just the ionic form of sulfur. Okay, so we have a metal and a non-metal, so it's ionic. Okay. Well, what did I do? Oh, I'm pushing buttons on my pen. Okay. But if we look at nitrogen and fluorine, nitrogen, fluorine, we have two nonmetals, so it's covalent. Now I'm not going to go through every single one of these with y'all, okay? But I will go through the ones that, are reasonable to go through. We have ammonium phosphide. So our ammonium was one of those polyatomics. So it was NH4 plus 1, remember? And phosphide is just phosphorus. So this is a ionic, this is a polyatomic ion, okay, so good. Last one, chlorine gas. If you remember, chlorine is a diatomic molecule, which means two atoms, right? So this is Cl2. If you have two chlorines, okay, two chlorines, that's two nonmetals. So this is also covalent. Good. Okay. So the reason we need to know whether or not they're ionic or covalent when we first start is so that we know how to name them. So if we're dealing with an ionic compound, we need to use our charges. And if we're dealing with covalent, we need to use prefixes. Okay. Now, charges, I feel like we had a lot of issues with this, so try to get this in your head, okay? Charges is when we split our periodic table at carbon, okay? And this side went -3, -2, -1. So like this whole column is -1, -2, -3. Then when we go on this side of carbon, it's +3, +2, +1, okay? Whole column. My cat is trying to get my attention. Okay, good. So let's talk about this ionic. Like I said, only for ionic, okay? Okay, so if we look at our ionic problems, we'll find sodium, which is Na, and it's in our +1 column. Okay, and we have sulfide, which is in our -2 column. This is when we flop our charges, okay? So this one will go here. This one will go here. So we have Na2S. Okay. Okay, now let's do another ionic. So whenever we have these polyatomic ions, these are the ones that we need to put in parentheses, right? NH4? I left out a 4 earlier, I apologize. NH4 plus 1. And then we have phosphide, which is in the -3. Okay, so we took this one, put it here, this one, put it here. Good. Okay, now let's talk about our covalent ones. Okay, I'm gonna erase some of this because it's getting a little bit hectic. There we go. Obviously, pause the video as you need. I'll be jumping around. Okay, so our covalent says to look at prefixes, right? So our prefixes are di and hexa. We have nitrogen. Di means 2, so 2 nitrogen. Fluoride. Hexa means 6, 6 fluoride. We love covalent bonds, right? Okay, they're so easy. They tell us exactly what they need and how many of what they need. I know this one's a little bit tricky because it should be like dichloride or, something crazy. Not necessary. Chlorine gas, Cl2. We should know that, okay? Okay, good. This one is kind of a trick question. This is a metallic bond, and they don't really follow the rules. So if you did not know how to answer that one, no big deal. Okay, so we'll move down here. Compare and contrast the following: solid, liquid, gas. So what I'm really looking for here, whoa, what did I do? I moved my stuff around. Okay. So let me edit. Let me see what I did here. Oh goodness. Okay, there we go. All right. So compare and contrast following. I don't care how you do this. If you want to do it with pictures, you can. If you want to do it with words, you can do that too. I'm gonna do it with pictures. So our solid, it's really asking like, what are the molecules doing? So our solid molecules are super, super tightly packed, right? Like this. And while it seems like they're not moving, staying still, that's fine, but really they're vibrating in place, okay? And our liquid molecules are a lot looser and they kind of flow around each other and make room. Like they're a lot easier to get along with. Okay? And our gas molecules are just freaking crazy. Like they're flying off the handle. Okay, nobody knows what gas is doing or why it's doing it. Or okay. Another way that you guys can talk about this is the beaker thing. I know we did this in class. So if you have a beaker and I put some air in here and put a lid on it, obviously it's going to fill up the whole beaker, right? So it takes the shape and the volume of container. Okay. A liquid though, I have a beaker and I put some water in it, put a lid on it. It does not fill up the whole container, right? It just stays happily at its little line. So this is just the shape. Okay. And then if I have a beaker and I put I don't know, a penny, put a penny in it, put a lid on it. Obviously that penny does not give a crap that there's a lid on top, right? It's just hanging out. So it does not take the shape or volume. So I'm just going to write neither beneath it. Okay. I know my handwriting is so bad, but if you're listening, it's eh. Hopefully you're listening. That way you know what I'm writing. Okay. Um, Compare and contrast the following element, mixture, compound. So element is really self-explanatory. Okay, it's literally if it is on the periodic table and it's not bound with anything else, it's the element. So if I have copper, I'm sorry, not copper. If I have carbon, it is an element. If I have 17 carbons, it's still an element. If I have diamond, which is made up solely of carbons, it's still an element. Okay. Mixtures. So did you guys hear my voice crack? Okay, so mixture is just two things mixed together, right? Obviously. This can be like blood, uh, water and sand. Okay, just mixtures. Compounds are things that are chemically bound, which makes sense, right? Because that's all we talk about when compounds are chemicals, okay? So like H2O, chemically bound. Okay, last part. So if we're talking about types of solutions, this is old stuff, okay? Like beginning of first semester stuff. So homo means same, hetero means different. So whenever we talk about types of solutions, when we say homo, we mean evenly mixed. So it's the same throughout. And a common, well-known example of this one is sweet tea. Okay. By evenly mixed, I mean like assuming there's not like a pound of sugar at the bottom. Okay. So like all of the tea should be the same sweetness. Okay. Or air, okay? Most air consists of the same percentage of elements. Okay. The other is hetero, which means different, so it's uneven. Okay. And some examples of this are just like milk in your cereal. Like, obviously these are not mixed. Cereal. How to spell that word? Obviously these are not mixed evenly, right? Like every time you get a spoonful of Fruity Pebbles, you're not going to get the same number of pebbles in every spoon, right? Okay. Okay, so we did most of this stuff together. And you guys can name the rest of these on your own. And hopefully I'll get better at writing and I will upload another video soon. Okay, talk to you guys later.